Welcome to MEI Mechanics. We're on the topic of Impulse and Momentum 1, Introduction, and this is video 1.4, Momentum and Impulse in 2D. Now, we've mentioned quite a few times that momentum and impulse are both vector quantities, although we've so far only restricted ourselves to one dimension. So the vector nature of these things really just showed itself through them possibly being positive or negative. But of course, where vectors really become useful is when we're dealing in higher dimensions. And so we'll be looking now at problems in 2 dimensions. And to help us with that, we'll use the IJ base vector notation most of the time. Now, if you haven't met this notation before, it's very simple. This base vector I is the same as the column vector 1, 0. And the base vector j is the same as the column vector 0, 1. And so that means we can write any vector, like for example 3, 4, as 2 parts, one of which is a multiple of I and one of which is a multiple of j. So the vector 3, 4 can be written as 3i plus 4j. So in this first example, we've got a mass of 0.5 kilograms and it's initially stationary, and then it's struck with an impulse of I plus 5j, and we need to find its new velocity. Now remember, we've just said that the impulse is equal to mv minus mu. In other words, it's the change in the momentum of an object. Alright, now in this case, the impulse we're given, it's I plus 5j, and the mass is 0.5, and we don't know this final velocity v. But this initial velocity u, well, we're told it's stationary, so that thing is just equal to 0. So we have I plus 5j equals 0.5v. So this is a very simple case of just multiplying by both sides by 2 to get rid of that 0.5, and so we'll have 2i plus 10j. Alright, now that's the final velocity. It's possible that we might sometimes also be asked to find the final speed. So in that case, I would just find the speed, and I can write the speed using v without an underline, because then that's indicating that it's a scalar. And because these are the 2 components, horizontal and vertical components, we can combine those using Pythagoras' theorem and find that the speed is the square root of 2 squared plus 10 squared. So that's square root of 104. And that is approximately 10.2 meters per second. Okay, so this time, this example 2, it's not as simple as the previous one because we have an initial velocity which is non-zero. So we've got an initial momentum. So the first thing to do is to work out the initial momentum. So that is the mass 0.5 multiplied by the initial velocity, which is 3i minus 2j. So that is 1.5i minus j. And that means that the final momentum must be the initial momentum, which is 1.5i minus j, plus the impulse, because remember the impulse is the change in the momentum. So that is so that means that if I take the initial momentum and add the impulse, that's the change that we have in the momentum, we'll get the final momentum. So I'm going to add I plus 5j, which gives me 2.5i plus 4j. Okay, now remember the final momentum, that is equal to the mass, which is 0.5 times the final velocity. So that means that the final velocity is equal to, by multiplying through by 2, is equal to 5I plus 8j. And then part B of this question is asking us to find the speed and the kinetic energy of the ball after the impact. Now if you remember from the first example, finding the speed is just a case of taking that velocity, which is 5I plus 8j, and treating the components of that as the short sides of a right angled triangle and applying Pythagoras' theorem. So that means that the speed is simply the square root of 5 squared plus 8 squared. So that's the square root of 89, which is about 9.43 meters per second. And we're also asked for the kinetic energy. Remember, the kinetic energy is a half mv squared, so that is a half times the mass, which is 0.5, times the square of the speed. Well, if I know that the speed itself is the square root of 89, that means that the speed squared is 89. So I don't lose any accuracy there. That's a nice little thing to do. And so that works out as about 22.3 joules. Again, that's to 3 significant figures. So that concludes video 1.4, Momentum and Impulse in 2D, and also concludes the topic Impulse and Momentum 1, Introduction.